Hello everyone, welcome back to our premium course. Today I will focus about load on structures. Now start from the load on the water pole. The structural plan top view, the depth is minus 1.4 meter and the thickness of the water pool is 20 cm. There are this load and light load on the water pool. The deep load, the surface of the motor and the floor tile, and the light load is the surface of the water. We can consider the water as the deep load or light load. In the critical case, I use the water as the light load. We had to calculate the water pressure applied at the base of the water pole and at the wall of the water pole. We should know about the density of the water. We use 10 kN per cubic meter and the depth of the water is 1.2. So the applied load 12.0. 1.2 multiplied with 10 is equal to 12.0 kN per square meter. This is the lateral water pressure applied at the base of the water pole. How to calculate? Pressure of the water is equal to density of the water. Density multiplied with depth of the water. The density is 10 kN cubic meter multiplied with 1.2 met, so it's equal to 12.0 kN per square meter. At the depth is equal to 0, the water pressure is equal to 0. At the depth is equal to 1.2, the water pressure is 12 kN per square meter. So for the water pool, we apply the deep load of the motor and floor tile plus with the light load, the water. Now we change it to square kN per square meter. Deep load, the motor, floor tile, the thickness is 0.05. The density of the material is equal to 23 kN per cubic meter. So the applied load is equal to 0.05 multiplied with 23 is equal to 1.15. Selling plus the MVP, you can apply 0.15, or it depends on the weight of the MVP. If we use the heavy weight, we should increase the applied load. At the light load on the floor, we apply 2.0 kN per square meter. According to the Euro Code EN 1991-11-2002. Category A, specific use area for domestic and residential activities, rooms in the residential buildings and houses, bedrooms and wards in hospitals, bedroom in hotels and hostel, kitchens and toilet. The view of the actions for the category A floors, we can apply from the 1.5 to 2.0, on the stair from 2.0 to 4.0, and the balconies 2.5 to 4.0 for the light load. This is the distributed light load on the square meter. If you want to apply the point load, you should apply it between 2 to 3 for the floor, and for the stair you should apply 2 to 4, and for the balcony you should apply 2 to 3. This is different from the distributed load on the area and point load on the floor. We also apply the reduced light load on the floor and reduced light load for the column. The formula apply for the reduced light load on the floor. The A0 is equal to 10 square meter and the A is the loaded area. For columns and wall, the total impact load from the several story may be multiplied by reduction factor alpha n. The formula should be applied when the number of story greater than 2 floors. About the loaded structural element from the same category. So the formula we use for the apply light load on the wall or on the column. The Tekla structural designer will be automatically using reduced light load when we include it in our model during analysis design. So everything will be run automatically. The basic wind speed for the wind load we apply 22 meters per second, and for the lateral earth pressure apply at the ground floor. At the basement, we should understand about the passive pressure and active pressure. It also depends on the type of soil, consistent soil or consistent soils. For the consistent soil, racking earth pressure 1957, we can use the formula Ka and Kp. And for the bare extension for the consistent soil, you can use the formula for the Ka active pressure and Kp for the passive pressure. At the rest pressure, K0 is equal to 1 minus sin phi spring. When you ask me a question when we should use the Ka, Kp and K0, the active pressure and passive pressure. Usually for the retaining wall, we can check the active and passive. In our model, we have only the active. The passive inside the building, no, we not apply the passive. We apply the active pressure on the wall. And right now, what is the coefficient factor? We should use Ka, Kp or K0. The answer for this model, we should use the Ka. Why? You see here, why not we use the K0 for the cantilever retaining wall? If you use K0, you have to make sure it is at rest, no displacement at the top of the cantilever retaining wall. This is very hard to ensure that the retaining wall no displacement at the top. I think the condition is very hard for contractor to guarantee you 100% no displacement at the top. No one can do that. So we usually use the Ka and Kp for the cantilever retaining wall. But for the building, you also can use K0. It depends on the construction stage. Now the basement wall, we backfill the soil before we construct the slab. Example, this is the slab shape. Yeah, this is the top slab and this is the bottom slab. So now the first condition, if we construct the basement and we build the wall, after that we backfill the soil. So in the case we should design by using the Ka. If you build the basement and the upper floor, you connect the wall with the upper floor. After that you backfill the soil. In the case you can use the K0. But always we use the active pressure on the wall. Do not use the K0. And Kp is different from the passive and active. You can check more in the picture. And the pressure, we also include the water pressure. So you must to check the water table wall at the ground floor where it present the water table wall. The deep minus 4 meter, 6 meter or 3 meter. You should must include the water pressure applied on the wall. And the gamma soil, we should use gamma saturation to apply the water pressure on the wall and apply the earth pressure on the wall. We use the gamma saturation. Do not use gamma dry to calculate the earth pressure on the wall. Thank you. I hope you enjoyed this tutorial. For more detail, ask me directly in group. Thank you.